In this video, I'll show you how to solve the ALEKS problem called theoretical yield of chemical reactions. The first thing that we're going to need to do in this problem is to take the words in this problem and use them to write and balance a chemical equation. So this is telling us that methane reacts with oxygen gas. So that means those are the two reactants. Methane is CH4 and it's reacting with oxygen gas to produce our products, CO2 and H2O. So let's begin by just checking to see if this is a balanced equation. One carbon on the left, one carbon on the right, 4 hydrogen on the left and only 2 hydrogen on the right. We can fix that pretty easily though. If we put a 2 here in front of the water molecule, now we have 4 hydrogen on the left and 2 times 2 is 4 hydrogen on the right. We have 2 oxygen on the left and 1, 2, 3, 4 oxygen on the right. So another one that's pretty simple to fix. If we put a 2 here in front of the O2, now we have 2 times 2 is 4 oxygen on the left and 1, 2, 3, 4 oxygen on the right. So this is a balanced equation. So this problem is asking us, what is the yield of carbon dioxide? So that means how much are we making? It wants us in units of grams. How many grams of CO2 are we making from the reaction of 9.3 grams of methane? So we have 9.3 grams of this molecule and 22.6 grams of the oxygen gas. So this problem is actually really tedious, not hard, but tedious. This problem is going to require us to do 2 separate calculations. Step 1, first thing we have to do is figure out how much CO2 we can make from the amount of methane that we have. So first thing that we're going to do is take that 9.30 grams of methane and figure out how much CO2 we can make. And then after we've done that, step number 2 is going to be to repeat the calculation, but this time starting with O2. So step 2, we're going to take that 22.6 grams of oxygen and use that to figure out how much CO2 we are going to make. And once we get both of those calculations done, we'll compare the numbers. So step 1, first thing we're going to do is convert the 9.30 grams of methane into CO2. 9.30 grams of methane, CH4. Multiply it by a conversion factor. We want the grams of methane to cancel, so we want grams of methane on the bottom, and we want moles of methane on top. We want to convert into moles, from grams into moles. We do that using the molecular weight or molar mass of methane, and that comes from adding up the masses of all of the atoms as we read them from the periodic table. So this is approximately 16 grams per mole. Now I do want to warn you, don't do what I just did right there. If you're actually solving these problems on ALEKS, don't round the masses of the atoms. That'll cause you to get the problem wrong. ALEKS needs you to be more specific. So you need to use the exact masses from the periodic table, whatever they might be, and get a more specific number here. But I'm just rounding to save time. Next thing that we're going to do is get rid of the units of moles of CH4, and we're going to convert into the units moles of CO2, the molecule that we're trying to calculate for. These conversion factors come from the balanced equation, the stoichiometric coefficients from the balanced equation. And the last thing that we're going to do is convert out of moles of CO2 and into grams of CO2 using the molecular weight of CO2, 12 plus 16 plus 16, except for you're going to do a more accurate calculation, not using rounded numbers. That's going to be 44 grams per mole. Let's make sure that we've set this up correctly and that our units are canceling. And it looks like it looks perfect. So we'll go ahead and carry the math out here. 19.3 divided by 16 times 44 is 25.575 grams of CO2. And that would be how much we could make from our 9.3 grams of CH4. Now remember, that's just part 1. We've got to repeat this calculation. We've got to do it a second time, this time starting with our mass of oxygen, 22.6 grams of oxygen. And now we need to calculate, second calculation, how much CO2 can we make from this mass of oxygen. So we want to start by canceling out our grams of O2, converting into units of moles of O2. That is 32 grams per mole. Each oxygen atom weighs 16. Now we need to cancel out our units of moles of O2. CO2 and convert into moles of our desired molecule, which is CO2, this conversion factor comes from the balanced equation. Their stoichiometric coefficient for O2 is 2. The stoichiometric coefficient for CO2 is 1. And then in our last step, we need to get rid of the units of moles of CO2 and convert into units of grams of CO2, 44 grams per mole. We'll double check to make sure that the units are canceling correctly, and then we'll carry out the math. 22.6 divided by 32 divided by 2 times 44 is 15.5375. That's how much CO2 we can make from 22.6 grams of O2. Now, this is where students a lot of times have a hard time knowing what are we supposed to do at this point. We've got two separate amounts of CO2. They both can't be the answer because they're two different numbers. So which one of these two is the actual answer? Which one of them is the theoretical yield? When you're looking at them, when you're at this point, the smaller of the two is always the accurate answer, and the larger of the two is a lie. We always have one, what we refer to as a limiting reactant. The limiting reactant is the reactant that produces the smallest theoretical quantity of our desired product. We only have enough O2 to produce 15 grams of CO2. So even though we have enough methane to make 25 grams, that doesn't even matter because we're going to run out of O2 as soon as we've made 15 grams of CO2. And it's literally impossible to make 25 grams of CO2 from this reaction. So every single time when you get to this point, you're always going to pick the smaller number. That is your theoretical yield to three significant figures, 15.5 grams of CO2.